All right, welcome, ladies and gentlemen, to Open Live Q&A. My name is Mr. McLogan, and this is week number 128 of the live streams, where I'm here to go ahead and take your questions, help you guys out with your own math. If you're taking any summer classes, or if you are just maybe already getting a heads up, or you are just here to hang out on a good Sunday night. This is as I mentioned, the 128th week here that I have been available for the Sunday night session, and yeah, basically. Um, it's here to have answer your guys' questions that you guys can go ahead and submit. And I can't believe I forgot to upload this in there. So if you do have math questions that you would like me to go ahead and get to, then you can. Oh, not the monthly live stream. Not doing that yet. No, not those either. Where'd those come from? I totally forgot about those. Okay, so if you have any questions, you guys can go to brianmclogan.com/Q&A. Or you can also go ahead and join my Discord server, which if you are taking a class for next year, I'd highly recommend checking out the Discord server. It's absolutely free, and it's really just a community for you to be able to ask your questions or help other students with their math and get better at math inside or during the process. So, Cameron, wait, do you type or you just get psychic power? Dreamland, good to have you on. And RJ and Omicron and Nadej, Misty, good to see you guys all on. And Bricks and Gabe, so happy to have you guys on. And yeah, so I do have a couple questions that were pre-submitted. Those are students that went to brianmclogan.com/Q&A. You can always go and type questions inside of the chat, but most time I am not able to get to the math questions. So if you have like a general question, I'll try to do my best to kind of, touch base on the chat. I do have it in front of me for right now. But once I start kind of doing math, a lot of times, people will type in math questions. And I just say, when you go to that link, you can go ahead and submit a picture, you can get a link, whatever else. So therefore I have time to kind of review it before I go ahead and broadcast it on my screen. All right, let's go and take a look at a couple questions here before we get started. So Cameron says, I'm getting ready for my first year of college, community college. Where am I supposed to start when talking about math? I would definitely just go ahead and talk, speak with the counselors. Where am I supposed to start when talking about math? Yeah. Typically you're going to take a kind of like a placement test if you have not already, where you kind of stand and what course you should be taking. And then, I would also maybe even reach out to your previous math teachers or your previous guidance counselor. Based on their experience, they probably should be able to give you like some recommendations where they would expect you to be. So therefore, if there is a disconnect on where you are expected to be and where you end up being, then you can kind of maybe bring that conversation up. But I would definitely speak with, your current advisor to kind of speak, what you're trying to obtain, what you're trying to get, and kind of where you're testing at and stuff like that. Yep, it's been over 2 years. It's been kind of crazy. And actually, it's been longer than that. I just didn't really keep track of that for long. But yeah, I did my first live stream. I used to do all my testing quizzes, which are now like inside of my course. So if you go inside of like my pre-calculus course, which we'll talk about later in the summer. But yeah, it's kind of funny. Like I used to, all my homework assignments, I used to do a live stream every night, and I would do the live stream for them. And like the quizzes, I'd go over the answers on there, which is good and bad. Like it was really difficult to go and do that because I was like, oh my God, I was so sick of doing live streams. But it was also nice because then I could just be like, kids, there's the answers, like go and watch the live stream. But again, for those of you that now are, this was again, probably 2018, 2019, or probably 2019. Yeah. So this was like 2019-ish. So, or yeah, 2018 as well. So, around in that time, online watching videos, it wasn't like that as much big of a deal. But obviously now, if you just said to your teacher, like, oh, just go and watch this video, watch that video, you're like, oh my God, I'm so sick of watching videos, whatever may be the case, especially like for the class, us doing so much online learning. So it was really helpful back then. I'm not sure, kind of at the end of the year or after when I was teaching during COVID and students were so used to like with online learning, I'm sure it probably like diminished the effect with that. Well, hey, Gail, I hope you're having a great summer. I am so far. Yes, I'm definitely looking forward to doing a lot more activities and everything coming up from there. Hey, Justin, good to see you on here at church. About to confess, I use photomath. Well, I'm not sure how you got photomath on exams, but I think photomath is an excellent resource to be able to use to help you with your learning. Not really sure if I'd agree with it on exams, but I'm glad you're in church taking care of your issues. The first live stream I went of yours that I went was the practice pre-calc exam, and also sounds like, well, yeah, it's coming up, right? So probably in July I'll start talking about that my pre-calculus exam and everything like that. And I'm looking forward to doing some other things with some other courses and getting ready. It was kind of crazy. Like I had so many big things. I was like, oh, I'm going to step away from the classroom. I'm going to have so much more time to do things and stuff like that. And I cannot believe how difficult this year was, even for myself. Thinking I would have so much more time, I'd be able to do so many different things. And it was really difficult. It was really difficult to kind of like organize my day. And it was really difficult to kind of create videos and plan videos. You know, I was just so used to making videos where I didn't have to think about what I was doing. I would just make videos based on what I was teaching. Right. So it was so easy. It was so natural for me. And then now it's like, oh, you're not in the classroom. Now let's start making videos. And it's like, what videos do I make and how do I make my videos? And yeah, it was difficult. And then obviously having an extra kid that adds in definitely some more time as well. Do you know the new math? I love the quotations that seniors can take. My son is able to take a different course other than calculus or the other one. Yeah, I'm just not familiar. I mean, I know new math takes on a lot of different, with like Common Core or whatever else. I'm not sure what country or state you're in, what that's referring to, but I'm not aware of like that course at all. Or at least what math, like, I'm not sure if it's like a, finance, more like the finance, or if there's definitely something completely different. Should I learn all math if just for say, yeah, I mean, I don't think there's any limitation on what you can or can't learn, right? Why did I bring this? Words over anything else I could have changed. It's not really math related. I mean, it's related to math, but it's not directly related to math. But I mean, I think that's the important thing is I want students to stay curious. I want you to be a lifelong learner. I think you should always, I think one of the hard things that students pitching themselves whole is like, oh, I got to learn this by this certain time. And if I don't learn it, then I'm stupid or I can't learn it or I'm never going to learn it. Right. No, you have your whole life to learn. Right. And you have your whole life to be curious and to put in the work and stuff like that. So, we all come up with different obstacles. We all kind of learn at different speeds. We all have different life experiences that are going to impact our learning journey. And I think it's just really important to like stay curious, and I think if you always are going to be curious on why things are the way they are, how things kind of work and what is more out there, the easier I think kind of learning kind of gets to be, I think the easier and more enjoyable learning can become. Because I think a lot of times we just put so much pressure and so much pressure and I'm not sure if I have the right word for it, like on the learning journey where it's like, we have to achieve like this and get to this and like so much stepping stones, like we have to do it this certain way. Right. And then we just kind of learn this joy of learning, which I think is really, something that I've seen been lost for a lot of students. Difference. Algebra 1, geometry, and algebra 2, and math 1, math 2. I'm assuming math 1, math 2, math 3 is integrated math. That's what I took actually when I was in high school, which is very similar to like the algebra 1. It's just they kind of blend a lot of the content. And so I think algebra 1, geometry, algebra 2, if I was going to give you a good distinction, I think those do get deeper into the topics, which I think is better for a mathematical foundation. Like I don't really think math 1, math 2, math 3 gave me a excellent, why am I getting this? No. I don't think that gave me I don't think math 1, math 2, math 3 gave me an excellent like mathematical foundation as I got into college and like for my math degree. However, I do think it does give a better like rounded foundation for math, for like just understanding math to be able to get on. So I only taught algebra 1. I never taught on the integrated system, so I can't really speak from that perspective. I only taught algebra 1, algebra 2, and geometry. But yeah, I think it's I think from teaching those three, I definitely got a lot deeper than I feel like I ever did in high school, like with the content. But I'm not going to say one is better than the other. I haven't taught or took both, as a student, so it's kind of hard for me to say. It's still helping how to watch your videos. Well, awesome. So happy to help. All right. All right, let's go and get caught up here. No, not finance. Let me check. We need versions for physics. As a math teacher, is there anything you would say that you struggle on? I want to be a math teacher. Awesome. And teacher my future. And I can definitely say calculus is not my strongest subject. Yeah, I mean, am I muted? I muted myself? Hopefully not. No, I think that's, yeah, I mean, well, I mean, first of all, like you can still learn calculus, right? If you took calculus once and you didn't do very well, like that's fine. Like you can take it again. And also like, and the same thing, like math, I mean, you can like, not a lot of the, you could also get a 6 through 9, and just go through that curriculum and like go through the math and build yourself up. Like, I think for the, I would definitely say, I mean, I struggled with math too. Like even the upper level classes. I mean, it was a struggle for me, right? I had to study really, really hard. Probably one of the hardest workers, or hardest studiers, probably in all my upper level math classes, right? Because I was a struggling student, so I had to work harder than them. I guarantee I was like not the smartest kid in all of those classes by far, right? There are some really, really smart kids that were in those classes, right? So I don't think don't treat yourself like if you're struggling in content, that doesn't mean you can't teach it or you're not capable of learning it or getting your degree, right? So, I would just keep on pressing on and keep on putting in the work. Okay, you're in South Carolina. Algebra with finances is what he chose. Okay, yeah, I mean, I'm assuming they've always had a lot of that course has kind of gone in and out with I'd probably say like we've had like a college readiness before, which is like probably similar, and then we've had like finance, math, and again I'm in Florida, but like I kind of feel like there's always been kind of like a turntable of like a kind of senior math or upper level class. Like I used to do math for college readiness. Then we did there's like there's been like 4 or 5 different classes that we've always had that have just kind of been like this rotating, just you want to give students like a foundation that necessarily don't need to be going into calculus, right? But they still need like a good solid math, foundation or review some of the concepts. So, I mean, I think I don't know the curriculum, like I said, I haven't teaching it, but I would definitely say, it's probably going to be a good review for moving on to the next level, whatever that may be. Do you know if acquiring requires a lot of hardcore math? No, I've never taken any accounting classes, so I'm not really sure of the exact math that you need to know. I would probably say it's probably good to like the nuts and bolts is probably going to be fairly basic, as most software is going to cover any more technical, like really in-depth stuff. However, as far as understanding like the process, like how things are being computed and like the theory of like a lot of those, I'm sure definitely some upper level mathematics is going to be, kind of needed or at least applied from on there. So if you're going to have to use that for as much of computation, I probably not as much, but probably for is like understanding a lot of the concepts for sure. Do you recommend self-studying for the AP BC exam in 9th grade, or is it too early? I mean, I have no idea where you are mathematically or what courses you've taken or anything like that. I will say I've never had a 9th grader take the APBC exam, like at least that I've known as far as I've been a teacher. So that would you'd be on the early side of it. I mean, I know there's been students that have taken it. So it's not like I'm not going to say here, like you can't do it or you're not good enough to do it. Like that's definitely not my place to say anything like that. But, I would just definitely talk with your counselor, definitely talk with your math teacher, definitely talk with your parents, because I mean, anytime you're going to be taking AP courses, it's going to require a lot of work. And I don't know what your other course loads are or what other time restrictions, you have, especially if you're going to do self-study. Are you going to be working with somebody like a mentor that's going to at least help guide you through the course? Because, when you're taking an AP course, your goal is to not only just learn the material, but obviously pass the AP, examination at the end. And I think having a good guide for that is going to be very helpful. It's not just learning the content, but it's also, being prepared for that exam. So, having the right resources that are given out by the, college, college board, that are, going to help you be successful. Like they give those out to a lot of instructors or people that have access to that. So I think, can you do it? Absolutely. Right. Is it right for you, or, should you do it? That's a different question that I can't really answer for you. So I would definitely speak with the people around you, counselor, math teacher, parents, to help you kind of make that decision. And then if you do decide to do it, with everything, then I would still recommend making sure you, get with somebody that can help guide you, or that's maybe in school doing it, that, you can benefit off of the resources that are provided by College Board. I'm not sure if they would provide those to you on like a self-study kind of idea. All right. Yes, you must obviously learn to integrate the curve of a line which expresses. Are you going into? Okay, I think you're. I think so. I'm assuming. Yeah, I mean, I have no idea, to be honest with you, what the math is going to be required, or what exactly you will need. So I apologize. I'll just, I would just make your general assessment from there, and, you should go through the math that you need. Do whatever, math that you're looking at your counselor, or looking at your, teacher, and then, kind of making that. And the other thing too is like, you can also speak with other people that are in those fields, right? That have already taken, like, what did you need to do? Obviously it does change through, university and countries and states. So, definitely, check with other people that are in the field of study that you want to go into, to see what they needed to do to obtain that. All right. Let me go see if I got any guys on questions. Why? I'm going to take off my overlays, because we don't need them. I don't want to be doing questions till 10 o'clock at night. Like I did actually last week, I was up to like 10:30 doing questions, because I took in so many questions, but it was crazy. All right. I think I only got one more question added out of that. And Dreamland. All right. Tangent line problem. You give me some calculus now. I have more calculus going on right now. All right. Use the definition of derivative to find f prime of f of x. All right. Let's go ahead and do that. I'm going to see. I'm going to have to work on that one. I do not know about Quincy High School. Amar, what is the best way to prepare myself over the summer to have the best chance of receiving an A in honors pre-calculus? Well, Amar, I have a amazing resource that is going to be coming up for you in the what is it, the difference there? There you go. I have amazing resources that I will be coming up to get you prepared for pre-calculus. And so that will be coming up in the beginning of July to help you prepare. Now, you don't need to. Now, this is kind of like is preparation for my course. You don't need to take my course to like utilize that, or to get, good at it. But what is so anyways, on my course, or at least on my preparation course, what I have is a kind of like a diagnostic test, diagnostic course. Actually, Justin was talking about it. And you basically just kind of sees where you're at. And then also has a multiple of videos of algebraic concepts, some trigonometric concepts to help you get prepared, for what you're experiencing in pre-calculus. And then obviously there'll be other opportunities and resources that I have. In addition to that, if you kind of need help through pre-calculus, throughout the year to kind of get you above that. But anyways, if that doesn't sound at all interesting or familiar to you, and you're just looking at like, what are some other things that I can do? I would really just say, I mean, it's kind of boring as it is. I mean, yeah, you can look at a pre-calculus textbook. Usually it's helpful if you do have like the previous syllabus from the teacher. So you can maybe get a copy of the syllabus of what you're going to be learning. I think kind of looking ahead and kind of reviewing some of the concepts, maybe every single one of those chapters has like some getting ready for that chapter. Like you can kind of like look over and get yourself familiar with some of the beginning concepts. I also think, if there's like a summer packet that's available, obviously go and do that. You can obviously definitely go and look at your previous course that you took, assuming probably like an algebra 2, and go back through that material, right? Review that material. It's a lot of pre-calculus does handle a lot of algebra 2 concepts, especially functions and polynomials, radicals, rational functions. A lot of that stuff comes back up in pre-calculus. So I definitely go back and review a lot of that content. I think is going to be really helpful for you. And also you can go back and review trigonometry from like geometry, like the special right triangles and trigonometric functions. I think that stuff would be helpful. Now, again, I have all of that in my Getting Ready for Pre-Calculus course, which again is free. But I'll be talking about that in July because I'm not ready to re-release it back in from there. Let me go back. There we go. Let me go and write because I forgot. Come on. Limit as x as h approaches 0. There we go. All right, and that's going to be of f. What's it? The minus fx. Over h. All right, let's go and give that a key. All right, thank you so much for advice. You're very welcome. What is your highest level math? The highest level math I took was, basically I got my, let's see what I get. I basically got my bachelor's degree in mathematics. Okay. All right, we have actually a lot of calculus, which I'm actually going to be doing some more calculus on coming up, because that's one thing I want to get back into is doing some more calculus. So I will hopefully have some more calculus coming in on my channel and everything else. But until then, let's go ahead and do some math and finish it up. So how's it going? Okay. All right, so now let's get into some of the math questions that were submitted. So the first one is, I think evaluate. Now, I think I saw the students comment. They wanted me actually to evaluate these solutions on the interval of -4 pi. Actually, let's do red. So they wanted to actually do this to -4 pi to 4 pi. Crazy. Well, again, you can always go ahead and check in with Mathway. So, like Mathway or like Photoshop, like those are tons of websites to go and check your answer. But I'll go ahead and do my best I can. Yeah, get some sleep. Go back, do a quick review of all your stuff. You have it tomorrow, right? The main thing you want to do is, get yourself in a good mindset and breathe, right? Get some good sleep, breathe, drink some water, right? And yeah, study, but don't stay up all night, right? Get some good sleep and you'll be all set. All right. So in this example, I recognize here I have a sine squared of theta, a cosine squared of theta, or beta, sorry, and then a 3 sine of beta. So, excuse me, because I'm tired. One thing I recognize here whenever I'm dealing with sine squared and cosine squared is the Pythagorean identity. So just remember sine squared of beta plus a cosine squared of beta is equal to 1. Okay, now the reason why that's important is because I don't really want to deal with these all in terms of sines and cosines. I want to deal with these just in terms of sine. So the first thing I'm going to do is I'm going to rewrite a a negative cosine as a sine plus sine of square root of beta plus 1, right? Because if you subtract a cosine to the other side, then you'd have negative cosine of beta, right? And then you'd have to subtract a 1 over here. So therefore, I can rewrite this as a sine square root of beta plus 2 minus, let's see, a sine square root of beta minus 1, right, equals a 3 sine of beta. Okay, so again, what I did is I simply just got the cosine square root of beta to the right-hand side, and I got the 1 to the left-hand side. That's how I was able to get this expression. Now I can go ahead and distribute this. And now it looks like I have a quadratic equation, so let's go ahead and get this over to the other side as well. So, all right, so we have a sine square root of beta plus 2 minus sine squared of beta. Let's see, that's going to be a plus 1 equals a 3 sine. Why am I doing sine squared? It's not sine squared. Sine of beta. Okay, so it's a quadratic, so I'm going to get this sine to the other side. That is not, is that a sine squared? Yeah, it is a sine squared. Okay. That wasn't the same answer I was looking at. Okay. Well, all right. That's actually even easier. Maybe I typed it in wrong, or I'm doing something wrong. Does anybody see anything? It could be for high school. It could be high school or college. I mean, it's a decent, nothing crazy with the trig. But yeah, it's trigonometry. Usually be like in a pre-calculus course. You typically see something like this. I don't think there's anything wrong here. All right, so let's go ahead and subtract. So therefore, hold on a second. Did I type that in wrong? For some reason, I checked this one. I usually don't have time to check any answers, but I want to see. I did not. This is not the answer that I was looking at. Sine squared. Yeah, that was not the same. I did type it in right. And the answer I looked at, I just wanted to make sure like the answer was nothing. I wanted to make sure the problem wasn't like crazy or there wasn't anything I was missing. And it showed me an answer that made sense, but this is not showing me that answer. So now I'm trying to think of what the heck did I do wrong? You just got to get over the hump. That's it. You just got to get used to calculus. Now it's, see, this one says no. Huh. Sine squared plus cosine squared equals 1. So that would be a minus, because if you have the minus cosine squared, I'm not sure where that's annoying. Because that's correct, right? Because when you subtract a cosine squared of beta, you have a sine squared of beta equals a 1 minus a cosine squared of beta, and then you subtract a 1. Equals a negative cosine squared of beta. And that's a negative 2, because they got a 3. No, so they didn't get the 3. How'd they get a 2? And then they got a 1. I don't know. I'm seeing this as, it's so weird because I'm looking at Symbolab and I'm not seeing how they went from their answer because I'm not seeing anything wrong that I did with my answer. But hopefully I'll post this answer here and hopefully somebody will be able to see like, yo, you forgot to do this step, or I'm missing something mentally, but I'm not seeing what I'm missing. Come on. So if anybody sees this and they want to let me know in the chat, I will be very happy to concede my issue. Because they went from here, right, which is basically what I did. So you subtracted the tree sign, fine, right? And then they replaced everything in terms of sign. So they replaced the cosine squared in terms of sine, which I did right here. But when you do that, I'm getting distributed, and then I'm getting a +1. So that's why I'm getting a 3. I'm not getting this when rewriting my identities. Subtract 3 sine, yes, and then rewrite using identities. Now, obviously, I could go ahead and pay for their system, but I'm not going to do that. So maybe anybody will see where I made a mistake, and we'll come back to it. All right, so verify the conditions of Rolle's theorem for fx equals sine of pi, or x over 2. On the interval, on the closed interval of pi halves to 3 pi halves, then C, that satisfies the conclusion. So just remember Rolle's theorem, I think it was like the mean value theorem. Again, I haven't taught calculus in like 2-3 years, something like that, so it's been a while. But if I remember correctly, Rolle's theorem, the main thing is that, it has to be continuous function and on the interval, on the closed interval, and I think differentiable on the open interval, as well as f of a. Well, Dreamlet, if you can go ahead and pay, then I would be greatly appreciated. And if you can submit it into the open Q&A for me, I would appreciate that. And I'll go and take a look. F of A equals a F of B, right? So let's go and check out, look what that is. So if I said what is F of pi halves, then I would get a sine of pi halves divided by 2, right? So what is that? Well, that is the same thing as the sine. Oh, well, first of all, is this a continuous function, x over 2? Yes, right? Is that going to be differentiable? Yes, right? If you look at the sine graph, right? So we're good there. So main thing is we just want to make sure, is the f of pi halves equal to f of 3 pi over 2? So pi halves divided by 2, that's really the same thing. Remember, dividing by a whole number is the same thing as multiplying by a fraction, right? So therefore, that's the same thing as sine of pi over 4, which is equal to the square root of 2 over 2. So now let's go and take a look at 3 pi over 2. So that's going to be the sine of 3 pi over 2 divided by 2, which is equal to a sine of, verify. I'm not seeing that's going to be the same. Sine of 3 pi over 4, which is equal to a negative square root of 2 over 2. So they need to be the same. So I'm not sure how we can confirm now that the derivative has to equal 0 on that. What is going on? What is up with today? What's up with tonight? We're getting 2 problems off the bat that are not working. What the heck is going on here? All right, let's make sure I simplified this correctly. So that's 3 pi over 2 and pi halves, right? So pi over 2 divided by 2. So you multiply by 1/2, multiply 1/2. That equals a pi over 4, right? And then 3 pi over 2 divided by 2, right? Multiply by the reciprocal. 3 pi over 4. Good. Now let's go and check the unit circle. Pi over 4, 2 pi over 4, 3 pi over 4. Yeah, so that's going to be square root of 2 over 2. This is going to be a negative square root of 2 over 2. Oh, maybe it's just verifying. It doesn't say verify the conditions of Rolle's theorem for this, and then find the value C that satisfies the conclusion. Oh, well, then we got to go ahead and, but I'm not seeing that it's going to be set equal, verify. I'm not seeing that those conditions are going to be verified from there. What is going on here? This is why I usually just take a look at calculus stuff and I'll Volvo, because I'm not sure what that, that's so weird. Sine of, yeah. And I don't know. If anybody's seen another mistake from there, maybe tonight's not my night. Let's go through some limit problems. Because obviously I'm not doing anything right. How do you find the tangent of this one? All right, let me go and take a look at that question. So they did 1 minus cosine squared. Okay, so what did I do? Oh, I replaced that with, oh, I'm an idiot. That's right. Okay, thank you. Yeah, I'm an idiot. Come on, what am I doing here? Yeah, you got to replace cosine. Yeah, duh. Okay, so let's go back to this problem. Thank you, Dreamland. I appreciate this. All right, so I just needed to see my brain is not functioning very well. So, how can I delete you? I don't need you. Okay, cool. All right, yeah, I didn't do the math wrong. The math's right, but I did this step wrong, which obviously I knew was wrong because it wasn't getting the right answer. Okay, so what you need to do, I need to replace cosine, right? So, yeah. I was going as like a negative cosine, which you can't do that. You don't want to replace the negative cosine because this is a minus a cosine. So you got to replace the cosine. I don't know what I was thinking. That was just kind of crazy by me. All right, so there's sine squared of beta plus cosine squared of beta, right? So I got to replace that, and I just incorrectly did that. So if we go ahead and subtract a sine squared of beta, wow, I don't even remember ever making a mistake like that. Probably did before. Okay, so that's a 1 minus a sine squared of beta. Okay, and then if anybody else wants to verify that f of a does not equal f of b, I am not seeing how that is coming through. So, and I believe that that is the one condition that we need for Rolle's theorem to be able to satisfy to find the value of c. All right, so now, so what I'm going to do here is I'm not going to replace this. This is actually going to be a 1 minus sign. That is correct. Okay. So therefore will be a 1 minus sine squared of beta. Okay, so then we'll go ahead and distributive property there. That's now going to turn that to positive. That's going to be a minus, and then we'll subtract the 3 sine, right, over. Okay, so that becomes a, so let's see what we get. We have a sine squared of beta plus 2 minus 1 plus a sine squared of beta is equal to a 3 sine of beta. Okay, so subtract 3 sine of beta, subtract a 3 sine of beta. Still can't write right now, so therefore that becomes a 2 sine squared of beta. Let's see, minus a 3 sine of beta, and then plus 1 equals 0. Okay, so what I want you to recognize is this is a quadratic, right? 2x squared minus a 3x plus 1 is equal to 0. So immediately when you see a quadratic, you should be thinking factor, 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 right? How can I factor this? Well, you can write this into a product of 2 binomials, right? And then, I'm sorry, not the 2 binomials. And last 2 numbers need to multiply to give me 1, but need to add to give me -3. So therefore, it looks like I'm going to have a -1 and a -1, right? So, all right, that's an x. So x minus 1, that's going to go and satisfy there. So now what we're simply going to do is we're just going to replace the x's with a sine of x, right? Because we're not really doing it with x's. I just did that because it's easier to go ahead and factor. So therefore, I can break this up as a 2 sine squared of beta minus 1 equals, not equals. Let's just write it as a 0 product property first. Times a sine of beta minus 1 equals 0. What am I doing? Jeez, slow down, dude. Because tonight is not my night. Okay, now I can apply the 0 product property, set them both equal to 0. Now in this case, why am I writing the squared? Oh my God. I need to stop. Okay, so that's the factored form. 2 sine of beta minus 1, sine beta minus 1 equals 0. Now I can set those both equal to 0, and therefore I go and solve. So to save myself some time, I'm just going to go and do that. So therefore I get a sine of beta is equal to a positive 1/2, and a sine of beta is equal to a positive 1. Okay, now let's go back into the unit circle, because again, we want to go on this interval negative 4 pi to 4 pi. So what we want to do is look at when are these solutions going to be occurring. So we have sine of theta is equal to 1. That's going to occur here, right? And that's going to occur every every 2 pi. Okay, so we have that answer is what? Pi halves. And then we have sine of theta is equal to 1/2. So that's going to occur that's going to occur 1/2 square root of 3 over 2. No, so that's going to be these two angles, which is going to be at a pi over 3 and a 2 pi over 3. Okay, so to not make things overly complicated or quick, what I'm going to need to do is just go ahead and keep on adding 2 pi to each one of those. Now, again, I can keep on adding or subtracting 2 pi as long as I stay within this interval. So my answer here is beta is equal to a pi over 3 plus a 2 pi n. My beta is equal to a 2 pi over 3 plus a 2 pi n. And the last one, put that over here. And then my beta is equal to a pi halves plus 2 pi. Okay, now it's really important to understand that 2 pi is the same thing as 6 pi over 3, right? So what I'm going to do is I'm going to keep on adding and subtracting that 2 pi into there. So let's go ahead and take a look at all the answers here. So, all right. So we have our first set of solutions, which is on the unit circle, pi over 3. I'm not going to do these in order. 2 pi over 3, and then pi halves. Okay. Now, let's go ahead and add a 2 pi, which is really a 6 pi over 3. So that would give me a 7 pi over 3. That would give me a 8 pi over 3. And there would be pi over 3 plus pi halves. Now you got to get common denominators. So pi over 6. Oh my God, that's going to be annoying. Man, this is not a fun problem. Why did we give me this problem? Okay, so 6 pi over 3 plus pi halves. So 3 over 3 and a 2 over a 2. So that's going to be 12. So that's going to be 15 pi over 3. Okay. All right. So now we added 2 pi to all of them. Now we could also subtract 2 pi to all of them, right? Because we can go in the opposite direction. So if we subtracted a 6 pi over 3, then we'd be left with a negative 5 pi over 3. We would have a negative 4 pi over 3. And then we could also do a subtract that. So then we could do a pi halves minus a 6 pi over 3. And again, do the same thing. So that'd be 3 over 3 and be a 2 over 2. Okay. So why did I do that? Oh, it doesn't matter that way. All right. So that'd be a 3 pi minus a 12. So that'd be a negative 9 pi. No. 12, 3. So negative 9 over 6. Right? Did I do that right? 12, 15, I guess. And then this would be, 15 pi over 3. Yeah, it's a 15 pi, right? Yeah, 15 pi over 3. Okay, which is really 5 pi. And then this one then would be a negative 9 pi over 3. So I'm just going to write it like that. Okay, so that was adding 2 pi in both within that direction. Now, again, what we need to understand is like how big is 4 pi, right? So because if you think about this, if 2 pi is 6 pi over 3, well, 4 pi over 3 is going to be a 12 pi over 3, right? That's the same thing as 4 pi over 3. So if you look at this, like I can't go larger than 12 pi over 3, right? So I can't add or subtract 2 pi any larger. So notice how this is larger than a 12 pi over 3, right? So this one actually does not count. And again, did I do that right? That doesn't. 2 pi. Yeah, so that'd be larger. Well, pi. Seems like that should not work. Pi halves plus a pi over. Oh, that's not 6 pi over 3. I did that wrong. That's a 9 pi over 3. I just added that wrong. There you go. That's a 9 pi 3. Okay. But all of these, I can't add or subtract 2 pi again, right? So I can't go. So this is my first answer, first round, right? Here's where I added a 2 pi, and here's where I subtracted a 2 pi. I can't do that again and fall within the restriction of negative 4 pi and positive 4 pi. So therefore, that's going to be my final answer. All right. I'm not sure if I made a mistake here, if anybody wants to check that one out. All right, and state whether the limit is equal or unequal to the given value of c, to the value c. All right, so what we're gonna do is let's do the limit on this side, and then we'll do f of c on this side. All right, so when c equals 1, the value is equal to 1. Okay, now what is the limit at 1? So the limit at 1, that does not exist, right? Because you can see from the left-hand side, we're approaching 0. From the right-hand side, we're approaching 1. So this does not exist. So those are not the same. Let's go to question number 2. The limit at number 2 is going to be equal to 2. Okay, so f of c, or f of 2 is equal to 2. The limit, again, does not exist, right? Because from the right-hand side, we're approaching 2. From the left-hand side, we're approaching 1. So again, this is another DNE. Okay, let's go and take a look at 6. Over at 6 here, looks like we have a value here, which is going to be at 5. And you can see from the left as well as from the right, right, because this graph keeps on going up, from left and right, we're both approaching 5. So that is going to work. Those are going to be the same. At f of 3 here, the limit or this value does not exist, right? So that does not exist. However, the limit from the left and from the right is both approaching the value of 2. So the limit exists, but the value of the function does not. But that's okay, because the limit is just talking about where we're approaching. And then c is equal to 4, so let's go to 4. And again, it looks like the value here is at 1. And again, we're both approaching that from the left and from the right. Okay. All right. So let me get to over here. Where was that? Huh. Sorry about that. All right. Now let's get to the last one. So use the definition of derivative to find f prime of x for f of x equals 1 over x plus 2. So I'm assuming you mean the definition, like the difference quotient here. And so basically all we're simply going to do here is go ahead and rewrite this. So I can have the limit as h approaches 0. And then now I'm going to replace an x with a x plus h. So this would be a 1 over a x plus h plus 2 minus a 1 over a x plus 2 all over an h. Okay, so now what we want to simply do is go ahead and simplify this equation. I don't know, it's been so long since I did anything from here. So I guess in this case, what we would need to do is get common denominators. So I would need to multiply by a x plus 2 over an x plus 2. It's been so long since I did this. X plus h plus 2. Then multiply x plus h plus 2. I'm going to not worry about the denominator here at the moment. So therefore, when I do that, I get a x plus 2 minus a x plus h plus 2. Make sure you put that in parentheses. That's very, very important. All over a x plus h plus 2, right? All over an h. And again, that's the limit as h is approaching 0. Okay, so now we go ahead and distribute this. And what we are going to get here is the limit as h is approaching 0 of a x plus 2 minus an x minus an h minus a 2 all over an x plus h plus 2 all over an h. Okay, so now we see that the h's are going to add to 0. My 2's are going to add to 0, and I'm left with this a negative h, right? Now, algebraically, what else can I do here? So it's going to give me a positive h. So the limit as h approaches 0. Where am I looking? What is this? What was the original problem? As f approaches 0, find f(x). Oh, okay. And yeah, you could just use the quotient property for that, but let's just go and see what we get. Yeah, I'd have to go and see. So therefore, that's going to be, that's actually a positive. Sorry about that. That's a positive h, right? No, it's a minus h. I was right. Never mind. So therefore, I have a negative h all over x plus h plus 2 divided by h. Okay, so now what I can do is multiply by my reciprocal in this fraction, right? So we have a fraction here in the denominator, and we have a fraction over here. Okay, and then now these are going to divide out. Those are going to multiply the 1, and you're left with the limit as h approaches 0 of a negative 1 all over. No, don't write limit notation like that. So you'll be left with a negative 1 all over a x plus h plus 2. And now you can plug in a 0, which is going to give you a negative 1 all over a x plus 2. And so therefore, f prime of x should be a negative 1 over x plus 2. And hopefully I did that correctly, because it's been a long time since I did that. But yeah, you can basically see, I mean, you're just plugging it in from there. You're just going to be plugging it in from there, and then just kind of simplifying it. So definitely it's a lot of opportunities to make mistakes. I've already had some issues making mistakes today, so hopefully that was not one. But otherwise, guys, I will look forward to seeing you on next week's live stream, where I'm here to answer your questions. And again, if you do have more questions, go ahead and check out brianmclogan.com/Q&A, or you can definitely go ahead and check out the Q&A, or you can go and check out my Discord server, which is also in the link. All right, guys, I hope you have a great week and night. I'll see you guys. Let's go. I got that right. Awesome, Dreamland. Awesome. All right, guys. Cheers.